This is lesson 2. I will express metric mass measurements in terms of a smaller unit. In lesson 1, we were talking about metric units of measurement, and today we're going to talk about metric mass measurements. So in your math journal, I want you to turn to the next blank page, and I want you to write today's date, and I also want you to write lesson 2 metric mass. And when you're finished with that, I want you to write mass equals weight, because when we talk about mass, we're really talking about how much something weighs. So that's what we're going to be talking about today. Okay, so before we get started, it's really important that you kind of have some kind of benchmark to compare these weights with. In the United States, we don't talk about kilograms and grams too much. We mostly talk about pounds and ounces. So it's important that you have some kind of visual image of how much a kilogram weighs. So if you take a look at this dictionary weighs about 1 kilogram. Also, a larger water bottle that's full of water weighs about 1 kilogram. But then the smaller measurement of mass in metric units would be a gram. And a gram can be compared to the weight of a paperclip or the weight of a dollar bill. So obviously this is much lighter. Okay, so in your journal, I want you to draw this chart. I want you to label it mass, and I want you to label one side kilograms and the other side grams, and then I just want you to go through here and fill out all the parts that I've already seen that are already filled out in this chart. The first thing that's really important for you to understand is that there are 1,000 grams in a kilogram. So it takes 1,000 paper clips to equal the weight of that dictionary. So we can always think about patterns. So if we have 1 kilogram, and that equals 1,000 grams, if we have 2 kilograms, then that would equal 2,000 grams. Issues with that. All right, so if I have 3,000 grams, how many kilograms would that be? 3. Why don't you try to go ahead and fill out the rest of this, and when you're ready to check, come back and we'll check to see how you did. All right, so this would be 4,000, 5, 6. You're probably starting to see the pattern. 7,000, 8,000, 9, 9,000. You're probably thinking that's really easy. And it is easy. And this is why most of the world uses the metric units, because they're in groups of 10, and it makes it so easy to go from kilograms to grams. It's easy to remember, and it's also easy to convert. All right, so let's just do a little bit of practice. You don't have to write this in your journal, but I just want you to kind of do this with me. So if you had 1 kilogram and 500 grams, how many grams would that be? So remember, there are 1,000 grams in a kilogram, so that would be 1,500 grams. 1 kilogram, 300 grams. That would be 1,300 grams. 5 kilograms, 30 grams, that would be 5,030 grams. Now we're going to go the other direction. If I have 2,500 grams, that is 2 kilograms, 5 grams. 5,005 grams would be 5 kilograms. I bet you saw the pattern in that too. All right, so let's take a look at your problem set. Okay, so we're going to kind of complete the same chart that's very similar to what you just did in your journal, so this should be pretty easy for you. It's got a little bit bigger numbers, so I want you to try to do this by yourself and come back and check. But if you cannot, remember, it's always okay to just follow along with me, but I want you to try to do some of it by yourself. All right, so if we have 3 kilograms, that's going to be 1,000 grams. 4,000 grams, that would be 4 kilograms. Now we're kind of getting off pattern, but I bet you can figure it out. So 17 kilograms would be 17,000 grams. 20,000 grams would be 20 kilograms. And 300 kilograms would be 300,000 grams. All right, so this is kind of like what we just did together in our lesson. So 1 kilogram and 500 grams would be 1,000. Now I have 3,000. 715. So why don't you try some of these by yourself and then come back and check. 17,084 grams. 5,009 grams. Now I gotta go backwards. So 7 kilograms. 481 grams. 210,000 grams. Okay, so let's go to the bottom of this page. Going to be just a little bit tougher. So I've got grams minus grams. So this is basically just subtraction. So you're going to take your 3,715 and you're going to take away 1,500. I want you to try to do this by yourself and then come back to check. So this is pretty easy because I'm ready to subtract in every place. So the answer would just be 2,215 grams. Now here it gets just a little bit tougher. So before I can take away 1,000 kilograms, there's a couple of ways to do this. I can count up from 237 to 1,000, or I can just subtract. So I'm going to say that 1 kilogram is the same as 1,000 grams minus 237 grams. So I'm going to have no thousands. That's going to be 10 hundreds. I'm going to decompose one of those. But I have 10 tens. I'm going to decompose one of those. So now 3, 6, 7, that's 763 grams. Now you'll notice that the directions here say express the answer in the smaller unit. So between kilograms and grams, which one would be the smaller unit? We said grams. So what that means is we have to change this to grams. But I think that I'm going to go ahead and add the kilograms together and then express it in the smaller unit at the end. Okay, so I'm going to start with the smaller unit. So 991 plus 9 would be 1,000 grams. And then I have 25 plus 24, which is 49 kilograms. So 1,000 grams is the same thing as a kilogram. So basically this equals 50 kilograms, but I have to express it in the smaller unit. So 50 kilograms would be equal to 50,000 grams. Okay, so again, I have to subtract. I'm going to run into a little bit of an issue here when I see that I can go ahead and subtract the kilograms, but look what happens when I try to subtract the grams. Not going to exactly work, is it? Because I can't take 990 grams away from 650 kilograms. So what I'm going to do is I'm going to go ahead and change this all over to grams. So I have 27,650 grams minus 20,990 grams. And now I'm just going to decompose. So I don't need to decompose in the ones, but I do need to decompose in the hundreds. It's going to give me 15. And in the thousands, I'm going to need to decompose so that I have 15. Now I can just subtract. So I have 0, 6, 6, 6. So that gives me 6,660 grams. Now, at the bottom of this page, notice it says express the answer in mixed units. So that means they want kilograms and grams. So if I'm trying to take 14,000 kilograms, 505 grams, and subtract 4,288 grams, I'm going to change these grams to kilograms and a mixed unit before I subtract. So instead of subtracting 4,288 grams, I'm going to subtract 4 kilograms and 288 grams. I hope you can read that because it's kind of small. All right, so I'm going to have to decompose right here. So this 100 is going to become a 4, and the tens place is going to become 10. But I'm going to have to decompose that and make that 9, and the 5 is going to have to become 15 so that I can subtract. And then I'm good everywhere else. So 15 minus 8 is 7. Remember, this is a 9. So 9 minus 8 is 1. 4 minus 2 is 2. And 14 minus 4 is 10. So my answer would be 10 kilograms, 217 grams. Same thing here. I have to express the answer in mixed units. So I'm just going to change this to kilograms and grams. So 57,000 grams would be 57 kilograms, and then 481 grams. So when I add, I'm going to have 9, 13, and that's going to give me 1,139 grams. And then kilograms, I'm going to have 62 kilograms. Now this is kind of an improper mixture here because I should, instead of saying I have 1,000 grams, I should go ahead and change that to say I have 63 kilograms, 139 grams. All right, let's do a little bit of problem solving with this. Okay, all right, so I'm going to hide the answer there. All right, so you can see that we're going to start with the RDW process. It tells us it wants us to draw a tape diagram. So it says use a tape diagram to model each problem, solve using a simplifying strategy or an algorithm, and write your answer as a statement. So one package weighs 2 kilograms, 485 grams. Another package weighs 5 kilograms, 959 grams. What is the total weight of the packages? So the first thing I'm going to do is think about what's my tape diagram going to look like. So this is how I drew my tape diagram. I had two parts and it was wanting to know the total. I used W for the missing factor that I'm looking for. You could have used any letter. You could have just used the question mark. So by looking at my tape diagram, I know to find the total, I need to add. So I want you to go ahead and try to add these together and then see if you get the same answer as me. Okay, so first I added together my grams and my kilograms, and then you can see that I ended up with more than 1,000 grams. So I separated that into 1,000 grams and 444 grams so that I can make this gram a kilogram. So my total was 4 kilograms, 444 grams. So the answer is the total weight of the two packages is 8 kilograms, 444 grams. Okay, I'm back. I had to stop and let my dog in. Okay, so let's take a look at problem number 5. Okay, so again, we're going to use that RDW process. We're going to read, we're going to draw, we're going to write. So together a pineapple and a watermelon weigh 6 kilograms, 230 grams. If the pineapple weighs 1 kilogram, 255 grams, how much does the watermelon weigh? So again, think about what your tape diagram would look like. This is going to give you an idea of are you going to add or are you going to subtract. So I know that the total was 6 kilograms and 230 grams from the problem. And I know that the pineapple weighs 1 kilogram, 255 grams, and I'm trying to figure out the weight of the watermelon. So since I have the whole and I have one part, to find the other part, I'm going to have to use subtraction. So I want you to try to write your subtraction problem and try to subtract it and then come back and see if you get the correct answer. Okay, so whenever I was subtracting, I had to do some decomposing here, and in the end I ended up with 4 kilograms, 975 grams. The watermelon weighs 4 kilograms, 975 grams. One more problem here. All right, so the way you pronounce this is Javier, but it wouldn't matter what you said, how you pronounce that name, the problem's still going to be the same. So Javier's dog weighs 3,902 grams more than Bradley's dog. Bradley's dog weighs 24 kilograms, 175 grams. How much does Javier's dog weigh? So think about what could you draw and what would your tape diagram look like so that you could figure out how much Javier's dog weighs. This is one way to do it. I drew this tape diagram as a comparison. You could have done it where you just drew Javier's dog and divided it into two parts. One part being the weight of Bradley's dog and the other part being the 3,902 grams that it weighs more. This is just one example. So I used D for dog to see how much Javier's dog weighs. But by looking at my tape diagram, in order to figure out how much Javier's dog weighs, I'm going to have to add these two numbers together. So I want you to try to write that addition sentence and try to solve it. See if you can figure out what to do when you've got all of these grams and 24 kilograms and 175 grams. See what you would do there. Okay, so this is what I did. Before I added, I took the 3,902 grams and made it 3 kilograms and 902 grams so that I wouldn't have to come back and do it again at the end. When I add them together, I ended up with over 1,000 grams. So I went ahead and used a number bond here to separate the 1,000 grams from the 77 grams to make this 28 kilograms and 77 grams. So Javier's dog weighs 28 kilograms, 77 grams. Last problem. The table to the right shows the weight of 3 grade 4 students. How much heavier is Isabel than the lightest student? So I want you to stop for a minute and think about what would you draw and what would your number sentence look like and see if you can solve this one all by yourself. When you're ready, you can come back and we'll work through it together. Okay, when I got ready to draw my tape diagram, the first thing I noticed is I had to go over here and look at the chart and figure out who was the lightest student. So I compared Irene and Sue, and I saw that Sue actually weighs 200 grams more than Irene. So really I didn't even need Sue to draw on my tape diagram. I just drew Isabel, and you notice I kind of abbreviated her name, and I knew that she weighed 35 kilograms, and then I compared her to Irene, which is 29 kilograms and 38 grams. So what I wanted to know right here was this difference. So in order to figure out this part, it's kind of like I had two parts, and Isabel's weight was the whole. So in order to figure out what this missing part was, I have to use subtraction. Okay, so I'm going to subtract, and I can already see that I'm going to have to take away 38 grams from this 35 kilograms, and there's no grams. So I'm going to just go ahead and call this 35,000 grams minus 29,038 grams. I just went ahead and converted this into grams really quickly. So I'm going to have to decompose. So that's going to give me 4,000 10 hundredths. I'm going to decompose so that I have 10 tens, and I'm going to decompose that so that I end up with 10 ones that I can subtract. So now I have 2, 6, 9. Oops, I'm going to decompose right here. I didn't look all the way over, did I? So now I've got 14. That's going to give me 5,000. So I've got 5,962 grams, or I can say that that is 5 kilograms, 962 grams. So my sentence would be that Isabel weighs 5 kilograms, 962 grams more than. That's not the only way that you could have written that sentence. There are lots of other ways that you could have written it and still made sense. So good luck on your exit slip.